Hello, thank you for joining this presentation today. I am Carolina Realini, a senior scientist in the meat quality team at AgResearch. I am based at the Joint Food Science Facility Tiohu Rangahaukai building at Massey University campus in Palmerston North. I will share my presentation. It is my pleasure today to present results from a study to answer a question that different players along the meat value chain have been asking for a long time. Does intramuscular fat level affect the eating quality of New Zealand lamb? I will start with a brief introduction about why intramuscular fat and its relationship with eating quality of meat. I will present some evidence from published international data. I will then present results from intramuscular fat and eating quality for New Zealand lamb, and finally discuss some implications and recommendations based on our work. So eating quality, defined by its palatability attributes, will determine consumer liking and their preferences, and will determine consumer purchase and repurchasing decisions, and also how much are they willing to pay for meat. And this is why eating quality is so important. Intramuscular fat has been identified as one of the significant factors that influence palatability through changes in flavor, juiciness, and tenderness of cooked meat. Now, over the years, farmers have been selecting for lean meat yield, increasing muscle depth, and this has been decreasing or reducing the amount of fat in the carcass and also intramuscular fat levels across the lamb carcass, with negative consequences on the eating quality of meat. Now, the importance of intramuscular fat in determining eating quality of lamb has been highlighted by work in Australia, where they have shown that all sensory traits increase their consumer liking scores with increasing intramuscular fat percent levels, and across 4.5% increase in the IMF range have led to consumer sensory scores increase of 10 units for juiciness, overall liking and flavor, 6 units for tenderness, and 3 units for odor. More recent study in the UK have also shown increases in consumer liking scores with increasing intramuscular fat percentage, with curvilinear response for texture and overall liking, and a linear response for flavor and juiciness. And in this study, intramuscular fat percentage accounted for 11% of the variation in overall liking. Now, how much intramuscular fat is in New Zealand lamb? Data from 1,700 lambs from different industry progeny tests have shown an average intramuscular fat percent value of 2.7, with a maximum frequency at 2.5%. Now, this scatter plot shows a positive relationship between carcass weight and fat depth of the carcass. And for a narrow range of carcass weight, this is the industry target carcass weight range, 17 to 19 kilos. For this narrow range, we see a broad range of fat depth in the carcass and also intramuscular fat percent in the loins from those carcasses. And we see the gray dots represented IMF values lower than 3%, and the green dots representing IMF values greater than 3%. And for this data set, about 70% of those carcasses had IMF values lower than 3%, which is a threshold value that has been identified for assuring eating quality. Early work in the US by Sable with beef, pork, and lamb have shown that a minimum degree of intramuscular fat in meat is necessary for acceptable eating quality. And results show that values lower than 3% of IMF were outside the consumer window of acceptability, and that an increase in IMF percentage from 1 to 3% corresponded to the maximum rate of increase in palatability. Now, more recent consumer studies looking at the relationship between intramuscular fat and eating quality of lamb have suggested intramuscular fat values between 3 and 5% to maximize eating quality of lamb. And from our last slide, we have seen that about 70% of New Zealand loin samples have values below 3% intramuscular fat. Now, all these studies have used animals that are different from those animals grown in New Zealand to produce lamb. And this is why we have designed a study here in New Zealand to answer the question, does intramuscular fat affect the eating quality of New Zealand lamb? And we set up a unique study where we have done or we have selected loins with increasing levels of intramuscular fat from a single flock. And I say unique because some of these published studies have conducted or have selected loins with specific levels of IMF, for example, contrasting low versus high and not looking at a linear increasing range of IMF. Other studies have also limitations because they have generated the range of intramuscular fat using animals with different genetic background or using animals that were fed different diets and also using animals that were slaughtered at different age or weight at a slaughter, which they all become confounding factors if they're not accounted for. So this is a unique study because probably very few countries in the world can actually get this set of unique samples. We identify 550 ewe lambs from one single PAMU farm. So all animals had similar genetic background, same diet, same age at the slaughter, and the same management. All animals were slaughtered on the same day last year in May at a Silver Fern Farms meat plant. The loin selection was done stepwise. So visual assessors, trained assessors visually selected 217 loins out of those 530 to achieve the target linear range of IMF, and representative samples of those 217 were freeze-dried, ground, and scanned using NIR, and the IMF value was predicted using a prediction equation with R square of 0.9, and 108 loins were selected based on the intramuscular fat predictions using NIR out of those 217. And following the NIR scan, we confirm those values with chemistry using gas chromatography. In this way, we were able to minimize the samples analyzed chemically. Finally, the 108 loins were stratified in 6 groups of IMF, 6 incremental groups of IMF with 18 loins in each group. This graph shows the carcass weight of all the animals and the 6 intramuscular fat percentage groups with mean values and the standard deviation. And we see that for a narrow range of carcass weight, we have a broad range of intramuscular fat values with an average carcass weight of 19 kilos, an average IMF of 2.9%, minimum value of 1%, and a maximum of 5.7% intramuscular fat. We carried out a consumer study at the Massa University food testing laboratory. We collected responses from 165 consumers in 18 sessions with about 10 consumers per session. Each consumer evaluated in each session 6 lamb samples that corresponded to the 6 IMF incremental levels, and these levels were the same distance apart in the IMF percentages. So lamb loins were sous-vide cooked for an hour at 58 degrees C, and they were finished in a hot plate to a final core temperature of 68 degrees and a medium degree of doneness, which we can see that the degree of doneness was fairly homogeneous across the 6 loin samples. Consumers evaluated the degree of liking using a scale from dislike extremely to like extremely for tenderness, juiciness, flavor, and overall liking. And they finally rated the overall quality of the lamb sample as unsatisfactory, good every day, better than every day, or premium quality. These are the results, and we have the consumer liking scores on the y-axis and the intramuscular fat percent level on the x-axis. And we see that tenderness, juiciness, and flavor scores show a similar response to incremental levels of IMF to the overall liking scores. So I will focus on overall liking. And we see that consumer overall liking scores increase with increasing levels of intramuscular fat percent up to level 4, with no further improvements in overall liking with further increases in intramuscular fat. We even see a decrease in level 5. Now looking at the consumer liking scores for the 18 loins in this level, we identify 3 odd samples that had unusually low consumer liking scores in that level. And when we remove those 3 samples, the average of that group is similar to level 4 and level 6. Consumer liking attributes were low to modestly correlated with intramuscular fat percentage, except for juiciness, with values close to 0.25 for tenderness, flavor, and overall liking. Overall liking scores were highly and significantly correlated with all the sensory attributes, mainly flavor, followed by tenderness and juiciness. And since all these palatability attributes are highly correlated with overall liking scores, we ran a cluster analysis on the overall liking consumer scores. Now, in the previous slide, we presented the response average of the 165 consumers. So that is the average of all consumer responses, but the average could be misleading when we have groups of consumers that are rating differently, that have different preferences for the samples. So we ran a cluster analysis that allow us to find groups of consumers with similar preferences. And we found 2 consumer segments for this data set. Consumers that were in cluster 1 were about 2/3 of the consumers, 111, and a smaller consumer cluster with 54 consumers, which is about 1/3 of the total consumers. And cluster 1 shows a linear response, a linear increase in overall liking scores from level 2 to level 5, with no difference between level 5 and level 2. Now, there is a difference response for consumers in cluster 2 to increasing levels of intramuscular fat. We see a curvilinear and inverted U shape in the consumer scores as we increase intramuscular fat, with a maximum of consumer liking for level 3 and 4 that correspond to 2.65 and 3.2% IMF levels. Now, when we ignore those groupings, as we have done before with the ANOVA analysis for the 6 categories, if we ignore those groupings and we apply regression models to the overall liking scores on the IMF percent values, we see different model fittings. And for all consumers, which is the red line, the best model was a quadratic model with maximum overall liking at 4% IMF. Now for consumers in cluster 1, which were about 70% of all consumers, we see a linear response. So we see a linear increase of 15 overall liking unit increase across 4.6% range increase for IMF. Now, when we look at the response for consumers in cluster 2, which was about 30% of consumers, we see a curvilinear response, a quadratic model fit with a maximum overall liking at about 3.5 IMF. Another interesting results from this study comes from the consumer evaluation of the overall quality of the sample, rated as unsatisfactory, good everyday, better than everyday, or premium for the 6 IMF levels. And we see significant differences for the good everyday and the premium quality categories. So a higher percentage of consumers categorize level 2 as good everyday, higher than levels 3 and 4. And particularly interesting, the premium category, where a higher percentage of consumers categorize those loins with higher levels of IMF as premium, particularly those from level 4 that corresponds to 3.2% IMF. Also, we can see that about half of the loins were categorized as better than everyday or premium, about 40% as good everyday, but there is still a 10% that was classified as unsatisfactory quality. So summarizing, we see that intramuscular fat is low to modestly correlated with sensory attributes, which indicates that it is not the only factor that determines eating quality of meat, but a significant one. When we look at data from all consumers, the model suggests 4% to achieve maximum overall liking, but minimum IMF level to guarantee consumer satisfaction around 3%. Now, a larger data set will be needed to validate this model. And when we do consumer segmentation, we find 2 consumer groups or clusters. The larger group of consumers, about 70%, show a linear increase. That is, overall liking increases with increasing levels of IMF. And we could describe this group as IMF lovers, the more the better. And then we find a second group of consumers, which is a smaller group, about 30% of the consumers, where they prefer IMF levels between 2.5 and 3.5%. We could describe this group as IMF optimizers, just the right amount. So the results from this study also support the idea that if we continue selection for bigger carcasses where bigger muscles and larger muscle area and more leanness without taking into account quality parameters, that can lead to a decrease degree of finishing of the carcasses and a decrease of the content of intramuscular fat, and consequently that could compromise consumer liking or decrease consumer liking. So we suggest to increase the proportion of loins with intramuscular percent values greater equal than 3%, particularly when we target export premium markets. And this can be achieved by a combination of strategies around a long-term genetic component with other strategies like modifications in the animal diet or product sorting for quality. We also recommend to look into other muscles beyond the loin muscle to see what is the consumer response to incremental levels of IMF beyond the loin in the carcass. And with that, I would like to acknowledge Pamu Farms and Silver Fir Farms for their support. I would also like to acknowledge the funding sources, AgResearch core funding and MBIE. I would like to thank my colleagues from AgResearch that participated in this work. And I would especially like to thank you for joining and listening. And please send me an email if you have any questions. I'll be very happy to hear from you. Thank you very much.